Hello students and welcome to Smart Kids Tutorials. In this video, we will be solving 6 riders based on Pythagoras Theorem. Let's begin with the first one. Given from a point O in the interior of triangle ABC, perpendicular OD, OE and OF are drawn to sides BC, CA and AB respectively. We need to prove that AF square, which is here, AF square plus, this is AF of course, AF square plus BD square plus CE square is equal to OA square plus OB square plus OC square minus OD square minus OE square minus OF square. Where is AF? AF is here, BD is here, CE is here, OE square, OE is here, OB is here, OC is here, OD is here, OE is here, and OF is here. In most of the times when now we know that we are doing riders based on the Pythagoras theorem. Now, but in the exam you would not be knowing whether it's based on Pythagoras theorem or not. But most of the time when you have got the squares coming, okay, of a particular length, then you should know that there is Pythagoras theorem most probably is involved in that. And here and especially when it says that there is something perpendicular, then 9 out of 10 times there's got to be Pythagoras theorem involved, okay, or the converse of it. So here we are dealing only with the Pythagoras theorem, not the converse of it. So we have got AF square. So what we, in this case, see we have got now where to start is difficult to find, but we can focus on what has been asked from us. So knowing about this one, this will come later. First we focus on how to get this one. And where do we start from? So we start from AF square, BD square and CE square. Where is AF? AF is here, okay, and it is part of this particular triangle OFA, okay, or AFO. So let us try to find out what is AF square. Let us try to find out what is BD square, and let us try to find out CE square. And since they are different parts, this is one AF square you'll get from this triangle, then BD square you'll get from this triangle, and CE square is from this triangle. So they are not connected with each other. But how can we connect them? It says AF square plus BD square CE square. So let's find out what is AF square, let's find out what is BD square, and let's find out what is CE square, and let's add them together, and let's see what we get. And from there onwards, we'll proceed to find out this part, the right hand side part of this particular first one that we need to prove. Okay, so let's begin first. So we write down that first proof, and down here, and here, I'll write it down here, proof, and then say AF square is equal to OA square minus OF square. And inside this triangle, okay, so I'll put over there triangle OFA, and I'll say by Pythagoras theorem, Pythagoras theorem, okay. So AF square is equal to OA square. So because the perpendicular is here, OA becomes the hypotenuse, but we are interested in AF square. So that's why we say AF square is equal to OA square minus OF square, okay. And similarly, as I said, we target BD and CD. So CE, so BD square, say equal to, and we'll mark this as 1. This is 1. BD square, which is over here, we'll say is equal to OB square, which is the hypotenuse, minus the other side, okay, that is OD square. We'll say triangle ODB, and we say Pythagoras theorem. Mark this as 2. Then next one is CE square, which is here. So CE square is equal to the OC square, which is the hypotenuse, minus the other side, which is OE square. We'll say triangle OEC by Pythagoras theorem, okay. Pythagoras theorem. Okay. Now we've got this and we'll mark this as 3. And now what we'll do is we'll add 1, 2, and 3. Okay, because we want to add AF square, BD square, and CE square. So we'll say adding 1, 2, and 3, we get, we'll write it over here, AF square plus BD square plus CE square is equal to OA square minus OF square plus OB square minus OD square plus OC square minus OE square. So I'm just adding the right hand side once we added the left hand side. Now, next thing, what I'll do is we will group two of them together. But before that, if you have realized, we have already proved the first part here. Okay. Now we can arrange them together. OA square plus OB square plus OC square. Okay, there's no need to arrange. If you want, you can do that. Let's do that. Okay. We say AF square plus BD square plus CE square equal to OA square. So all the positives together plus OB square plus OC square. And then all the negatives together, that is minus OF square minus OD square and minus OE square. Okay. So that's what was asked over here. Next, for the second part, which is A square. A square is where? Here. A is here. So in Pythagoras theorem, A square is equal to what? OA square plus OE square. So we have it over here. So that's what we will try to do over here. Okay. So we'll write over here the same thing. We're repeating AF square plus BD square plus CE square. And OA square, I'm going to put it with OE square. Just grouping it, regrouping it, that's all. Okay, plus OB square. Okay, where is OB? OB, if I group with OD, I will get BD square because OB square, if I group with OF square, I will get BF square. OB square minus OF square, I'll group together. And finally, we have OC square. OC square is here. Now, we need CD square. So, OC square, if I group with OD square, then I will get CD square. And it is here. OC square minus OD square. Okay. So, I can mark this as 4. And we can write over here that what we need is A square. So, A square, okay, is equal to, what is A square? A square here is equal to OA square minus OE square. So, OA square minus OE square, and this is in triangle OEA. OEA, and comma, Pythagoras theorem, we write Pythagoras theorem. Okay. And next one we'll take as we need a CD square. Okay. So CD square, where is CD square? CD square is OC square minus OD square, which is also over here. OC square minus OD square. And this is in triangle ODC. ODC, it's a Pythagoras theorem. Okay, Pythagoras theorem. And last one that we need is BF square. BF square is over here. BF square is OB square minus OF square. So BF square is equal to OB square minus OF square. And this is in triangle OFB. OFB. And this is also by Pythagoras theorem. Okay. And all this will mark as 5. And now all we need to do is substitute 5 in 4. Because you see OA square minus OE square is here, which is A square. OB square minus OF square is here, which is BF square. And OC square minus OD square is CD square, which is here. And that's what we need. So we can say substitute, we can say 5 in 4. And we will get AF square plus BD squared plus CE squared is equal to AE squared plus BF squared plus CD squared. Hence, proved. Okay. And with that, we complete this particular proof for this particular ride. Let's go to the next one. Next one, given ABCD is a rhombus, and you're asked to prove that BD squared plus AC squared, BD is here, AC is here, the diagonals, is equal to 4AB square. Okay. So you may be given this construction, you may not be given a construction, just given a rhombus. So assuming that you may not be given the construction inside, because it's mentioned BD squared plus 4AC square. I have drawn it already, equal to 4AB square. So I'll begin first with an assumption. So you can say proof. You can say let the diagonals AC and BD, AC and BD of rhombus ABCD intersect each other at O. Then you can say since diagonals of a rhombus are perpendicular to each other and bisect each other. Okay, we should know the property of the rhombus, that the diagonals bisect each other, okay, and they are perpendicular to each other. Bisecting each other means dividing this diagonal into two equal parts. So we say therefore AO equal to half of AC, okay, and BO equal to half of BD. AO half of AC and we have BO half of BD, because DO is equal to BO and AO is equal to OC, because they bisect each other. And also you can say angle AOB equal to 90 because they're perpendicular to each other. Okay. Then you can say now in right angled triangle AOB, which is this one, okay, where angle AOB is equal to 90 degrees, we can use a Pythagoras theorem. AB square is equal to AO square plus BO square. So because the right angle is here, AB becomes the hypotenuse. So AB square is equal to A square plus B whole square, and we say Pythagoras theorem. Right over here, Pythagoras theorem. Next, we can say AB square. Now AO we've got equal to half AC. We put half AC whole square, and BO we've got half BD. Half BD whole square. So you can say 1, you can say 2, you can say from 1 and 2. Okay. So we open the brackets. So because it's squared, it will become 1/4 AC square, and this will become 1/4 BD square. Okay. Then next, if we multiply by 4 throughout, multiply by 4 throughout. When we multiply by 4 throughout, 4 gets multiplied to AB square. 4 gets multiplied to this 1/4 AC square, and 4 gets multiplied to 1/4 BD square. This will cancel, and we get 4AB square is equal to AC square plus BD square. And that's what we need. Okay, where you can say hence proved. So this is how we solve this particular proof or right. Okay, let's move to the third problem. Third one, given coordinate ABCD is a rhombus whose diagonals intersect it here. See here it is given diagonals are intersecting at O. Now it says prove that uh, the fact that the diagonals are given, okay, and that also means that they are perpendicular to each other. It's a property of a rhombus. We are asked to prove AB square plus BC square plus CD square plus DA square. So sides of it, AB, BC, CD, and DA equal to the square of the diagonal, sum of the square of the diagonal. It's AC square plus BD square. Okay. So similar properties that we use in the previous one, we use here also. We write over here as proof. So we write and we begin. Similar thing, say in triangle AOB. Okay, this one. Okay, we say that AB square is equal to AO square plus OB square. AO square plus OB square. We write over here Pythagoras theorem. Okay, there because it is 90 degrees. Okay, we can write over here that AC is perpendicular to BD. Okay, diagonals you can say of rhombus are perpendicular to each other. Okay, fine. Then now we know that the diagonals bisect each other. So by the diagonals also bisect each other. So we can write AB square is equal to OA. Okay, we can write as or AO. We can write as half of AC. So half of AC whole square, and OB we can write half of BD, half of BD whole square. And here you can write reason since diagonals of rhombus bisect each other. Okay, diagonals of rhombus bisect each other. I will mark this, we'll open this bracket up. So we get AB square is equal to 1/4 AC square plus 1/4 BD square. Mark this as 1. Okay, and moving further, now this we got as AB square. Okay, then we go to BC square. So you can say over here in triangle BC is where here in triangle BOC. Okay, here you see AC is perpendicular to BD. Already given over there, don't write again actually. BOC, we write BC square is equal to OB square plus OC square. We write by Pythagoras theorem once again. Okay, and once again we can write BC square is equal to OB is half of BD, half of BD whole square, and half of AC whole square. Okay, and same thing, diagonals bisect each other. As the reason, we get BC square is equal to 1/4 of BD square plus 1/4 of AC square. We mark this as 2. Next, we go to CD square. So we say in triangle DOC, okay, say CD square is equal to OD square plus OC square. Okay, and this by Pythagoras theorem once again. Okay, and CD square is equal to OD is half of BD whole square, and half OC is half of AC whole square. And we can say over here diagonals bisect each other. So this will become CD square equal to 1/4 BD square plus 1/4 AC square. We mark this as 3. Then we have dA square. Okay, dA square. So here we have AB square, BC square, CD square, and D square. We found out AB square, we found out BC square, we found out CD square, and we need to find out dA square. So dA comes with here in triangle DOA. We write in triangle DOA, dA square is equal to OD square plus OA square. So OD square plus OA square. And you can say by Pythagoras theorem. And once again, dA square OD is half of BD and OA is half of AC. So half of BD whole square and half of AC whole square. And you say diagonals bisect each other over here. Okay, where diagonals bisect each other, we get dA square is equal to 1/4 BD square plus 1/4 AC square. Then we adding, can say 1, 2, 3, and 4. So when we add AB, we'll get AB square plus BC square plus CD square plus DA square, okay, equal to, and since, see, AB square is what? AB square is 1/4 AC square plus BD. So I'll mark this over here separately so you can have a look. Okay. Then what is BC square? BC square is here. Same thing. What is CD square? Same thing here. Okay. Now what is dA square? Same thing. They are all equal to 1/4 BD square plus AC square. Okay. Then you can say it will be 4 times. So this is 1, 2, 3, 4, right? So 4 times we can say 1/4 AC square plus 1/4 BD square. Now if we take out this 1/4 which is common to both of them outside, then that 4 and 4 will get cancelled and we'll be left with, therefore you can say AB square plus BC square plus CD square plus DA square equal to AC square plus BD square. Hence, proved. Okay. So with this we complete half of the video. 3 of them have been solved, 3 more to go. At this point, I would request you to hit the like button, share this video with as many friends and classmates as possible, and we have a WhatsApp channel. The link for that is in the description below. Please do follow that for more updates and more notes. Okay, and if you have not subscribed to the channel, please do subscribe so that you get new and latest updates on whenever a new video is posted. So let's continue. Fourth, given in triangle ABC, angle C is 90 degrees. P and Q are 2 points on the sides AC and BC. AQ, BP, and PQ are joined. We have to prove AQ square, which is over here, plus BP square here is equal to AB square plus PQ square. Okay, so let's begin with this problem. We'll say proof. Let's say in triangle AQC, where is triangle AQC? AQC. Okay, we know angle ACQ equal to 90 degrees. Therefore, we can say triangle ACQ is a right angled triangle. Okay, and you can say therefore by Pythagoras theorem. Therefore, by Pythagoras theorem, AQ square is equal to AC square plus PQ square. We mark it as 1. Where is that? AQ square becomes the hypotenuse because the right angle is here. AQ square is equal to AC square plus CQ square or QC square. Similarly, we can say can say in triangle BPC. What is BPC? BPC or BCP, anything can take. Okay, angle PCB equal to 90 degrees. Therefore, we can say BP square is equal to BC square plus BC square, and by Pythagoras theorem. Pythagoras theorem. Where is the BP square is here, BC is here, and PC is here. Okay. Now we mark this as 2. Now why we have taken BP square and EQ square? Because it's part of what we need to prove, EQ square and BP square. So it says AQ square plus BP square on the left hand side. So what we'll do, we'll add 1 and 2. So we say adding 1 and 2, we get AQ square. So we add the left hand side first and then the right hand side. AC square plus CQ square plus BC square plus BC square. Now we'll regroup this. I'll show you how. AQ square plus BP square, and AC square will group with BC square. I'll tell you why also. Wait. And CQ square will group with PC square. Okay. Now what is AC square plus BC square? We'll have a look where is AC and BC. AC and BC. This is right angle. If AC square and BC square is equal to AB square. So we write this as we'll separately write that AB square, and let us have a look at CQ square and PC. CQ is here, PC is over here. This is the right angle. That means PQ square becomes the hypotenuse. PQ becomes the hypotenuse. So PQ square is equal to CQ square plus PC square. Okay, so that's what we want to prove as well. So what we say is we'll mark this as 3, and then we'll say in triangle ABC, this big triangle ABC. Okay, we say angle ACB equal to 90 degrees, which is over here. And we say therefore AB square is equal to AC square plus BC square, and we say this is by Pythagoras theorem. Okay, that's what he says. And similarly, you can say in triangle PCQ. PCQ is here. PCQ. The angle PCQ is equal to 90 degrees. Therefore, you can say PQ square is equal to QC square or CQ square plus PC square. And again by Pythagoras theorem. Pythagoras theorem. Mark this, we mark this as 4, and we mark this as 5. So then you can say substituting 4 and 5, which is 4 and 5. 4 is here, 5 is here. We substitute the values, and substitute AC square plus BC square, right? In place of this, we put AB square. We put CQ square plus BP square is equal to, instead of AC square plus BC square, we put AB square. And in place of CQ square plus PC square, we put PQ square. And that's what we need. Okay. Then we say, hence, proved. So this is how you prove this particular rider. Fifth rider, the side AB, which is over here, of an equilateral triangle ABC. So that means ABC is an equilateral triangle. Don't go by the figure. It doesn't show that it is an equilateral triangle, but ABC by construction should be an equilateral triangle. Produced to D such that BD is equal to 2 times AB. And CM is said to be the median of AB, angle ABC. That means it will divide it into equal parts, which means AM should be equal to MB. Once again, I'll repeat that do not go by the figure. It doesn't look like an equilateral triangle ABC. Okay. So the figure needs to be redrawn to look like an equilateral triangle. So excuse the figure, but ABC is an equilateral triangle. Okay? And CM is the medium of AB. That means AM is equal to MB. And we are also given that BD is equal to 2 times AB. So we'll work with whatever we have been given. And we need to prove that CD square, which is here, okay, is equal to 7 times AB square. Where is AB square? Here. Okay. And this is shown to be as a perpendicular. So we'll work with that and Pythagoras theorem to achieve our target of CD square equal to 7AB square. Let's begin the proof. And we'll begin with first with whatever we have been given. BD equal to 2 times AB. And we say that it is given. Mark that as 1. We say AM is equal to MB. Okay, and you say since CM is median of triangle ABC. So AM is equal to MB. And therefore, you can say AM is half of AB. And we can say similarly, MB is also half of AB. Since see AM plus MB makes up AB. But if AM is equal to MB, we can say AM is half of AB. And similarly, we can say MB is also half of AB. And we mark that as 2. Now, MD, okay. The MD, which is this MD we can write as MB plus BD. MB plus BD, okay. Now, MB we have written as half AB. So we'll write half AB, and BD we can write as 2 times AB from here. Okay, so we can write from 1 and 2. So from 1 we get BD is equal to 2AB. So instead of BD I put 2AB. And from 2 we get that MB is equal to half AB. So see, ultimately we have to get everything in AB on the right hand side. That is why all this is being done. Okay. So we can say if we add this and take the LCM, we'll get MD is equal to 5 upon 2 AB. Mark this as 3, which we'll use later on. Then next we can say we take the triangle. In triangle CMD, angle CMD equal to 90 degree. Okay? And therefore we can say that CD square is equal to CM square plus MD square. CM square plus MD square by Pythagoras theorem. Okay, we say Pythagoras theorem over here. Okay, we say CM plus M square plus MD square. Now, CD square, right, same means CM square only be like that. And MD we've got 5 upon 2 AB, right? So instead of MD square, I'll put 5 upon 2 AB, whole thing squared. And next what we'll do is this CD square and the CM square. CM, which is over here, okay? This CM square, I'll put it as CB square minus MB square. So CB square minus MB square, okay? By Pythagoras theorem, you can write over here. And this will open this up squared, right? So 5 5s are 25 and 2 2s are 4 and AB square. And since we have got this CB square minus MB square, part of Pythagoras theorem, so you say by Pythagoras theorem. Pythagoras theorem over here, the reason for that. Okay. Next, now CD square equal to now CB square. Now CB is what? CB is part of this equilateral triangle. This is an equilateral triangle. Okay, funny. This ABC is actually an equilateral triangle, which means AC is equal to AB plus AC is equal to AB equal to BC. So we've got BC square over here, and BC square will change it to AB square. Okay, because it is equal. CB square is equal to AB square because it's part of equilateral triangle. Now, why we are changing it to AB square? Because we need everything in AB square on the right hand side. So we're going to put this, replace CB square with AB square. Okay, and MB. Now our MB is here. This MB also I'm going to change into AB because we've got this over here, MB equal to half AB. So minus, instead of MB square, we'll put half AB whole square plus 25 upon 4 AB square. Now, AB square we have got from this CB square equal to AB square. We can put as we can give a reason over here. AB is equal to CB, and you can say triangle ABC is equilateral triangle. Okay, equilateral triangle. And the other reason is which we've got MB is equal to AB from 2, and from 2 you can close this bracket. Now let's open up this bracket here. So we write over here CD square, AB square, we leave it the way it is. This will become 1 upon 4 AB square plus 25 upon 4 AB square. Okay. Next, what we'll do is we'll take the LCM for this so that the denominator becomes common, 4. So CD square is equal to, this will become 4AB square minus 1AB square. We can write it as just AB square plus 25AB square whole thing upon 4. Let's see what we get. So 25, 4 minus 1 gives us 3. And 3 plus 25 will give us 28. So 28 AB square whole thing upon 4. 4 ones are 4, 4 sevens are 28. And we get CD square equal to 7 times AB square, which is what we needed. And we can say, hence, proved. Okay. With this, we finish the 5th rider. Coming to the final rider, says given in triangle ABC, AB is equal to AC, AE is perpendicular to BC, and D is any point on BC. We are asked to prove AB square minus AD square is equal to BD into DC. Let's begin by saying proof. Okay. And say in triangle AEB, where is AEB? B, this one, AEB, it's a right angle triangle. Okay. And triangle AEC, where is AEC? AEC is here. Okay. We can say angle AEB is equal to angle AEC equal to 90 degrees. Okay. Then we can say since AE is perpendicular to BC. Okay. Both of these are 90 degrees. Then we can say that we are given AB is equal to AC, which is given to us. Okay. And we see AE is the common side. We say AE equal to AE, and we say common side. Now we've got a right angle, we've got a side, which also happens to be the hypotenuse on either triangles, and we've got a common side. So we can say therefore triangle AEB is congruent to triangle AEC. This would be by right hand side congruence rule. If you all do not know how it is RHS, see R stands for right angle. So we've got right angle. H stands for hypotenuse. So we've got AB and AC. How do you get AB and AC as hypotenuse? It is not even mentioned over here. Always remember the side opposite to the right angle becomes the hypotenuse. It becomes the longer side. And we have got another side. Any other side can do. We've got one side which is AE, common to both. And hence we can say by RHS congruence rule, the two triangles are congruent to each other. Now we can say B is equal to CE. Okay. Why? CP, CT. BE part of this triangle AEB and CE part of triangle AEC are equal to each other by CPCT. What is CPCT? Corresponding parts of congruent triangle. Okay. So here we'll mark this as 1. Next, we can say we'll take triangle. Yeah. So we need AB square. So right. AB square we need. So AB, yeah, in triangle AEB will take angle AEB equal to 90 degrees. Will be given. So we can say AB square is equal to AE square plus BE square by Pythagoras theorem. Okay. And this will mark as 2. Similarly, we can say that since we need AB square and AD square, right? We can say in triangle AED, angle AED is equal to 90 degrees. This triangle AED. You can say AD square is equal to AE square plus DE square. This would be by Pythagoras theorem. Mark this as 3. And then we'll say 2 minus 3. 2 minus 3. So here 2 minus 3. Let's see what we get. So that means AB square minus AD square on the left hand side. AB square minus AD square. And on the right hand side, we would have E square plus BE square. AE square plus BE square minus AE square minus DE square. Okay. Now, AE square positive and negative E square both will cancel out each other, and we are left with AB square minus AD square is equal to BE square minus DE square. Now, moving further, we have AB square minus AD square, and this B square minus D square, this is like A square minus B square, which can be expanded into A plus B into A minus B. So we can write this as B plus D into BE minus DE. Okay. Next, AB square minus AD square. So left hand side is what we actually need, but this side needs to be converted into BD into DC. So this BE B, we can convert this into CE plus DE. How is it possible? Okay, because we have put over here B equal to CE, okay, from 1. And BE minus DE will leave it the way it is, BE minus DE, okay, and right over here from 1 as the reason. Okay, remember B we converted to CE because we have already proven B equal to CE in equation 1. Now next, AB square minus AD square. C plus D. Where is C? CE is here and D is here. If we add them together, we will get CD. So we get CD. Okay. Into what is B minus D? BE minus DE will give us BD. Okay. And that's what we had to prove. Okay. It is BD into DC. What is BD into DC or CD? So that hence you can say it is proved. Hence proved. So with this, we can conclude this video on riders based on Pythagoras theorem. I hope you found this useful, this video. If you like watching this video, please hit the like button. Share this video with your friends as well as your classmates. And if you haven't subscribed to the channel, please do subscribe. As I said, any video that is uploaded, and you will get notification for that, and you will know that the new video has been uploaded. This video was requested by many, so hence I have done. There are many more videos that have been requested. As time permits, as much as I can do, I will upload more and more videos for your benefit. Okay, so thank you very much for watching, and remember there's also a WhatsApp channel. The link to that is in the description below. You can follow that channel for more updates, something that I can't put up on video, like notes or circular something that's on that channel. Okay, so thanks once again for watching, and see you in the next video.